Hello everyone, this is a video going over 10.1.1, what can I tell from a survey? Its association in two-way tables. So the first example we went over included Martha Fandalou's problem, where she was conducting a survey with 175 students. Some people had Pi phones, and some people had computers, and some people had neither. So we had to fill out a Venn diagram, but that Venn diagram was an issue because we had to keep adjusting our numbers based on how many had one, how many had only one, and how many had both or neither. So Venn diagrams tend to be a very difficult thing to work with when it comes to probability and statistics. So we flip our page, and it gets us to a two-way table problem. So 10-2 says, Really Bay said he could not figure out how to put the data from the previous problem into a Venn diagram because it was hard to find the number of students with both Pi phones and laptops. We can check what we're talking about here. How many people had both? So we're talking about the 7. That was difficult to find. So it's saying that Really Bay had a tough time figuring out how many had both Pi phones and laptops. So he put the information into a table instead. So question A says, complete Really's table to figure out the number of students in the missing cells. So using the table, we're going to figure out what numbers are missing. So if we use the totals, we're going to call this the one the grand total. That's important because we know every single one of these totals adds up to 175, and these two also add up to 175. So if we do a simple subtraction of 175 minus, for example, 28, we could figure out that missing number. 175 minus 28 is 147. Okay, we can also do the same thing here. By doing subtraction, we do 175 minus 44 and get 131. Now check this out. Once we have two numbers in a row or a column, we can figure out the third or the missing number just by doing subtraction. So it's sort of like a P-U-Z-Z-L-E. It's sort of like a puzzle. It's important to know how to figure out this puzzle because once we have the puzzle figured out, guess what? We can answer the rest of the questions. That's right. So by doing subtraction, we're going to get this number is 21. And if this is 21, these two numbers have to add up to 28. So this would be 7. These have to add up to 44. So that would be 37. And we have a completed table. Now, this one says, this is called a two-way table. Why do you think it's called a two-way table? So a two-way table is mostly to do with there are two variables or two things that we're comparing. Those who have Pi phones and not, those who have laptops and not. Sometimes it could be more than two variables. For example, it could be 9th grade, 10th grade, 11th grade, and 12th grade. But for the most part, we're comparing two different categories. Okay, letter C. How is the two-way table similar to and different from a Venn diagram? What are its advantages and disadvantages? So I'm going to write down the advantage for two-way tables. I'll say pro. All the numbers and totals are included in the total. We're talking the columns and rows. Versus a Venn diagram, those numbers are sometimes not even included at all. We'll leave that one out. We'll leave that one on the burner. So let's move on to question D. Question D, if we assume that Miss Fandalou's survey is from a random sample of students in her school, what is the probability that a student, what is the probability that a student at her high school has a Pi phone or a laptop? Now this is a key word here. Or means either. Or means they can be either have a PiPhone or a laptop. So we're looking at those people that have PiPhones or laptops. Now, do you think we should count these 7 people twice? Okay, so that's the key one. We're not supposed to include the 7 twice. So we're going to put a check mark on 37 and 7. Those are the people that have laptops, which of course adds up to 44. And then for those who have PiPhones, it's going to be 7 and 21. We know 7 and 21 adds to, that's right, 28. But we should not count these 2 twice. So there are 2 ways to do OR questions. The first way is we are going to just add up 37 plus 7 plus 21. Okay, we're talking about those 3 numbers. And we're going to divide that out of 175, which is the total or the grand total number of students. Now that's the first way, just to add up those 3 numbers. And the second way is to just use the totals. So if we just add up 44 and 28, but don't forget to subtract 7 because it's included twice, it's called the intersection. That is another way to get our probability. So doing this calculation, we're going to get 37 plus 7 plus 21.
That would be 65.
65 out of 175. Otherwise, we can do it this way. 44 plus 28 minus 7.
It's 65.
We also get 65. Now, if we just simply divide these 2 numbers, we're going to get our answer as a decimal or a percent. What is 65 divided by 175?
It's approximately 0.3714.
So approximately 0.3714, which is approximately 37.14%. Either of these 2 answers is totally great. Okay, our next question is, what is the probability that a student has a PiPhone? Let's find the number of people that have a PiPhone. So the number of people that have a PiPhone happens to be 28. So we're going to go ahead and say 28 people randomly chosen from a total of 175. 28 divided by 175.
It's 0.16.
Looks like it's exactly 0.16, which is 16%. Now note the difference. If it's approximate, we need to use these little squiggly marks. And if it's exact, like this one, we're going to use, of course, the equal sign. Okay, our next one is going to be, what is the probability that a student has a PiPhone and a laptop? So this means they have both. So the PiPhone and laptop is going to be 7. 7 people randomly chosen out of 175. 7 divided by 175
It's 0.04.
is exactly 0.04, which is 4%. Very good. Let's flip our paper. Okay, next up, we're going to look at a problem that's missing some numbers entirely, and we're basing it off of the words that are described here. So it says, there is a total of 145 students enrolled in Nugget High School. What an exciting name. I love it. There are 116 boys, so we're looking at a total of 116. And there are a total of 29 girls, so we're looking at 29 being the number there. And then it says there are 24 boys and 7 girls that earned A's for the first semester. So 24 boys earned an A, and 7 girls earned an A as well. We're looking at where A and girl cross, where A and boy cross. So it looks like these numbers are the numbers that are given to us. So if we go ahead and figure out the missing numbers now, we will be able to answer some questions. So the first question is, fill in the table to display all of the counts in each category. So the number of those who have A's, let's see, the number of those who have A's is 24 plus 7. 24 plus 7 is 31. Let's do some subtraction to figure out these missing numbers. 145 minus 31.
It's 114.
114. 29 minus 7, I know that's 22. 116 minus 24.
It's 92.
92, giving us all the numbers in our table. Next question, is there an association between gender and grades received? Now check it out. It does give us a little hint. In other words, is it more likely for a boy to receive an A versus a girl? So let's compare boy to receive an A, which would be 24 out of, we're talking out of the boys though, right? So 24 out of 116 versus the girls would be 7 out of 29. Let's compare those two numbers. 24 divided by 116.
It's approximately 0.2068.
Okay. 7 divided by 29.
It's approximately 0.2413.
So, is it more likely for boys to receive an A versus a girl? It looks like it's more likely for a girl to receive an A than a boy. So, is there an association? Yes, there is an association. Let's continue to move on. Letter C. Comparing percents, sometimes, I'll just say sometimes, can be easier in a relative frequency table. As you can see, the difference between this one is we have the totals versus this one, we're going to have the percentages. So it displays percents instead of counts. The percents you might have calculated in part B are below. 21%, I'd say approximately 21%, and approximately 24%. Notice how those two numbers are in our table. We need to fill in the values. So first off, let's start off with the easy thing. Everything should add up to what? Yeah, everything should add up to 100%. So let's carefully figure out all the missing values. 21 plus 24, 45%, meaning this should be 55% because 100 minus 45 is 55. Now we need to figure out the other numbers, so we need to divide 92 by 116. 92 divided by 116.
The answer is approximately 0.7931.
79%. Oh. Now check this out. The numbers that are in our table, what would happen? This would add up to 100%. This would add up to 100%. And that would not be 100. So there's an issue with this table, the way it's filled out. So usually the way that this table is filled out is based out of, not out of 116 or 29, but it's going to be out of 145. So the table that it's written this way has a little bit of errors the way that it's organized. Let's move on to the next problem. We'll come back to that one. Problem 10-6. According to the U.S. Census Bureau, of the 312.59 million people living in the U.S. in 2011, the number of people living alone is given in the two-way table below. So 312.59 million is shown here as the grand total. What's the probability of living alone? So look at the living alone category. 32.73 out of 312.59 million. 32.73 divided by 312.59.
The answer is approximately 0.1047.
That's going to be an answer of 10.47%. What's the probability of being 65 to 74? 65 to 74 is this category right here. Looks like there's going to be 21.4 out of 312.59. 21.4 divided by 312.59.
The answer is approximately 0.06846.
46, so I'll round that up to 5. That means it's going to be approximately 6.85%. What's the probability of being under 35 years of age? So 35 years of age would be under 35 would be including both this category and that category, because those are the people that are under 35 years old. So we're going to add up 111.12 plus 41.57, those two categories, and dividing it by 312.59. 111.12 plus 41.57.
It's 152.69.
152.69 divided by 312.59.
That would be approximately 0.4884.
Which gives us an answer of about 48.84%. So notice we needed to add two categories because those were both included under this idea that they were 35 years of age, under 35. Okay, final problem here for this question is what's the probability of being under 35 and living alone? So under 35 and living alone. Under 35 and living alone, we're talking about these two groups of people. Because those are the number of people that live alone and also are under 35. So we have to add up 1.45, 4.16, and divide it by the total of 312.59. 1.45 plus 4.16.
The answer is 5.61.
And let's divide those two numbers. 5.61 divided by 312.59.
It's approximately 0.01794.
So that's going to be giving us an answer of 1.79% of people are those who are under 35 and live alone. This means that those who are under 35 typically don't live alone because there's only 1.79% of the population.